Well, hello again, everyone. Um, I'm just going to record the lesson for 8.2. Now, here we say this is a relationships between sine, cosine, and tangent. This is very interesting. So hopefully that at least some of you would enjoy what is going on here. All right. So consider a right triangle. So this is a right triangle ABC. Now here is a 90-degree. So now, of course, now we do understand that this A and B, angle A and angle B add together, that will be 90-degree. Now, in other words, angle A will be 90-degree minus angle B, and angle B will be 90-degree minus angle A. So this is pretty straightforward. All right. Now let's take a look at between sine and cosine, and there's a very interesting relationship. Now sine A, we do know in reference to this angle A here, the opposite side is A, the hypotenuse is C, so that's A over C. Now here we go, that also equals to cosine B. Why? Because cosine B here, in reference to cosine B, the side of A now here, it is adjacent side. So adjacent over hypotenuse, then that is cosine B. So you see, isn't that interesting that sine A in fact equals to cosine B. Now similarly, cosine A is equals to sine B. So this in this very interesting relationship. Now therefore, then cosine B, what is cosine B? Already said cosine angle B is 90 degrees subtract angle A. So in this case, that if this is probably not using a good way to write because you used A and B, but it's the same thing. So we say sine A, sorry, what am I doing here? So sine A, it will be cosine B, right? Cosine B. Now, what is a B? Angle B is 90 subtract angle A. So therefore, then that is cosine 90 degree subtract A. I'm just shorten the angle A into A. See? So sine A equals to cosine 90 degree minus A. Where cosine is going to be the same thing. Cosine A equals to sine 90 degree minus A. Okay. Now let's take a look at what tangent. What's the relationship between tangent and sine and cosine? Okay, so we do know tangent. So this one, if we use the B here, tangent in reference to this angle, it is opposite over adjacent. So then that is, of course, B over A. Now sine B in terms of this, then that is B, the opposite, over the hypotenuse, so B over C. Now cosine B, it is the adjacent, which is A, over hypotenuse is over C. Okay, so now if we take the sine A or B, we're using B here, sine B over cosine B. So then we're just going to plug this thing in, which is sine B is B over C, B over C. Now over A over C, A over C. Okay. Now some of you could be pretty fast, so here we go. So what I would do is, well, this C and this C cancels. Well, that is just equals to B over A. And if you say, oh, hold on for a second, is that true? Okay, well, then we can do this way. B over C divided by, because this one is divided by A over C. Well, then that is B over C multiplied by C over A. Well, same thing, cancel. that that becomes b over a. Now what is b over a? B over a is tangent b. So then this equals to tangent b. So in this case, another relationship is therefore tangent of an angle. In fact, it is sine of this angle over cosine of this angle. So this is just, just the two ratios, as a matter of fact, organized in this way, then it becomes just the ratio for the tangent of that angle. Now there's another one is like, okay, how about the sine square and cosine square? If we add them together, it's very interesting. We add the sine and cosine, sine square and cosine square together, it becomes 1. It's like, oh, really? Yeah, let's take a look at here. So now again, we take a b, this angle b here. So in reference to angle b, sine b is again opposite over hypotenuse. So it's b over c. And cosine b is a over c, right? Because it's adjacent over hypotenuse. So cosine b here is this. Now sine b is this. I do not do the way that here they do. So what I'm going to do is that also mean sine square b. Then I'm just going to square this side. The right hand side becomes b square over c square. Okay, now very similarly, cosine square, the b, cosine b square, that I'm squaring the right hand side, that it becomes a square over c square. Okay, so in this case, if I add them together, okay, so you see, if I add sine b and cosine sine b square, add on cosine b square, that means I'm also adding this b square over c square, add on to a square over c square. So you can see this is a fraction, this is a fraction. So what is the common denominator? Well, the same denominator, very thankfully. So then this equals to the same denominator, which is c square. And then the top will be b square plus a square. Well, we go back to our beloved Pythagoras. So Pythagoras says, well, a square plus b square, what does that equals to? That equals to c square. So now the c square over c square, well, then that equals to 1. So this is how we prove that sine b squared plus cosine b squared equals to 1. Doesn't matter how much the b, doesn't matter how much the angle is. Could be sine 73 degree square plus cosine 73 degree square, that still equals to 1. Sine 1 degree square plus cosine 1 degree square, that still equals to 1. Okay? All right, so now this is just a further called a derivative of these formulas. So now what's going on here is it says that because sine square and plus cosine square equals to 1, so what's going on here is that they're saying they're using this one. So tangent square plus 1. Okay, so tangent square theta plus 1. Okay, now how much this equals? This equals to, there's a relationship, tangent equals to sine over cosine. So this means sine square the theta over cosine square the theta, that plus 1, right? Okay, well, then that means we're using the fraction plus a whole number. Then that common denominator is cosine square. Cosine square. So now we have sine square. Now plus 1 over, this has to be cosine square. I sometimes always just do not write this angle. All right, so then here we go. So again, you have to understand if this 1 now becomes a cosine square for the bottom, for the denominator, and the numerator has to be cosine square, right? So this 1 equals to this one. So therefore, now the common denominator is cosine square, so that is sine square plus cosine square. Okay, well the top is 1. When the top is 1, then over, and then there's cosine square at the bottom. So therefore, tangent theta square plus 1 equals to 1 over cosine square. Okay, so now so far what we have done is just so-called this 5 formulas, the 5 formulas. In the past, a lot of students always say, oh, do I need to memorize this? Do I need to memorize this? Oh yeah, for sure. But it's not straightforward memorization. If you understand how they came about, well, then it's not such a big deal to memorize it, is it? Okay, so anyways, yes, this needs to be not only memorized and see how we can apply these ones for solving problems. So now, for example, so we have, we know this, sine theta, this is a ratio. So 3 over 5. Now it's acute angle. Acute angle means we know this is within 90 degrees. So that also means we're in a right triangle. Now find the exact value of a cosine and tangent. Okay, so I think the very important thing is to draw a right triangle. This is very important. So as soon as you draw a right triangle, then you will see, okay, well, that's a theta. That I'm going to say this angle is a theta. You can say this angle theta, doesn't really matter. But if I say this angle theta, well, because the ratio is opposite, okay, well, then opposite side now is 3, and the hypotenuse is 5. All right, so from here, now we look at this triangle. Well, right away, we can calculate how much this side is. To go back to our beloved Pythagoras again. So now we understand using the Pythagorean theorem. Now we figure out, oh, A equals to 4. Good. Well, then what is the cosine? Cosine theta will be the adjacent over the hypotenuse. Therefore, it's a 4 over 5. Now what is tangent? Tangent is the opposite over adjacent. 3 over 4. Done. Okay. Now next example. So it says, okay, cosine now is this. Oh, right away, draw a right triangle. Okay, now we use this angle to say, okay, I'm going to let this angle be theta. Okay, so cosine, so then the adjacent is 2. Hypotenuse is 3. All right, so now we can use again and again Pythagorean theorem to calculate the b. Okay, now b is root of 5. Well, this time it is not a whole number. Okay, so it's root of 5. Now root of 5, now here we go. Now what is a sine? Now sine angle is root of 5 over 3. Okay, root of 5 over 3. Now the cosine tangent is root of 5 over 2. So here we go, done. Okay. What else? Okay, now here interesting thing is that we have a tangent that just like a decimal number. Okay, well, it is not a ratio. Take a look at here. All the other ones given is given as a ratio. Okay, now all of a sudden this tangent here seems like, oh, isn't that tangent should be a ratio? Why there's no ratio? Why there's just this number? Well, don't you think that we can change that into this one over 1? See, well, here you go. That's the ratio. So then in that case, draw a right triangle again. Okay, now draw a right triangle. Then here is my theta. Okay, now it's opposite over adjacent. So opposite is there. Adjacent is over 1. All right. Okay, well then again and again, we're going to use Pythagorean theorem. Now this time when we calculate the c is wacko. So there's here the example even kept as 4 decimal digits. So my goodness, so this one equals to c equals to 2.36 0.05. Right? Now from here, then again, well, sine is the opposite over hypotenuse. Cosine is the adjacent over hypotenuse. Done. All right. Well, then is this exercise set that you can now start having fun with. All right. Thank you for watching.